The seventh question is an exercise question. Show that the relation R and the set A is equal to 1, 2, 3 given by R is equal to 1, 2, 2, 1 is symmetric but neither reflexive nor transitive. Let us see solution. Given the set A is 1, 2, 3 and the relation R is equal to 1, 2, 2, 1. Only two order pairs we have. Clearly, R is not reflexive relation. Reflexive means for all the elements of the set A belongs to the relation. So, let us take an element 2 belongs to the set A. But 2, 2 does not belongs to R. Not necessarily 2. You can take 3. 3, 3 does not belongs to the relation. That's why it is not reflexive relation. Clearly, it is a symmetric relation. Symmetric means for all, if 1, 2 belongs to relation, if A, B belongs to relation, then B, A belongs to relation. 1, 2 is there. If you revert that, it is there in the relation. That's why it is a symmetric relation. ನೀವು ಕೇಳ್ಬೋದು ಸರ್ 2, 3 ಇಲ್ವಲ್ಲ ಸರ್ ಅಂತ. 2, 3 is to be there means there exist 3, 2 in the relation. If A, B belongs to relation, please understand the definition. If A, B belongs to relation, then only you can think of B, A belongs to the relation or not. So A, B ನೇ ಇಲ್ಲ ಅಂತ ಅಂದಮೇಲೆ B, A ಬಗ್ಗೆ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ. Okay, so it is clearly a symmetric relation. Then come to transitive relation. It is not a transitive relation. Recall the definition. If A, B belongs to R, B, C belongs to R, then A, C belongs to R. Take the example 1, 2 belongs to relation and 2, 1. This is B, this is also B. So then 1, 1. See, 1, 1 is not in the relation. 1, 1 does not belong to relation. That's why R is not a transitive relation. Next, 8th one, again an exercise question. Show that the relation R in the set A of all books in a library of a college is given by R is equal to the set of order pair x, y such that x and y have the same number of pages is an equivalence relation. Equivalence means what? Reflexive, symmetric and transitive. It has to satisfy all the three relations, then only it is an equivalence relation. Correct enough? So let us verify. Given the set of all books in a library of a college and the relation R equals set of order pair x, y such that x and y have the same number of pages. Let us check the reflexive relation. For all x belongs to the set A, x and x have same number of pages. The book x have the same number of pages. So x, x belongs to relation. R is reflexive relation. Therefore, let us verify symmetric relation. If x, y belongs to the relation, implies x and y have same number of pages. This implies y and x have same number of pages. For example, x has 25 pages, y have 25 pages means, so y and x have same number of pages, that is 25. So that means y, x also belongs to relation. Therefore, the relation R is a symmetric relation. Let us verify transitive relation. If x, y belongs to R and y, z belongs to R, this implies x and y have same number of pages and y and z have same number of pages. Say x has 100 pages, y has 100 pages, z has 100 pages, y has 100 and z has 100. So that means x and z also have 100 pages only. Correct, you know? So this means x and z have the same number of pages. This means x comma z belongs to the relation. Therefore, R is a transitive relation. So clearly, R is reflexive, symmetric and transitive. Since it satisfies all the three relations, hence it is an equivalence relation. Yes, the next question, 9th one, an exercise problem again. Show that the relation R in the set A is equal to 1, 2, 3, 4, 5 given by the relation R is equal to set of order pair A comma B such that modulus of A minus B is even is an equivalence relation. So this part is appeared in the year supplementary 2016 and annual 2018 in 3-mark section. The question is a continuation like this. Show that all the elements of the set 1, 3, 5 are related to each other and all the elements of the set 2, 4 are related to each other, but no elements of 1, 3, 5 is related to any of the elements of the set 2, 4. This is of course appeared in the CBSE 2019. Solution. Given the set A is 1, 2, 3, 4, 5 and the relation R is equal to set of order pair A comma B such that modulus of A minus B, modulus of A minus B is even. This is how they have defined a relation. Let us check the reflexive relation. Clearly, A minus A is 0. We know 0 is an even number. That means A comma A belongs to the relation. A comma B belongs to the relation means modulus of A minus B is even. A minus A belongs to the relation means A minus A, which is 0, is even for all the elements of A belongs to the set A. Therefore, R is a reflexive relation. Next, symmetric relation. If A comma B belongs to the relation implies modulus of A minus B is even. If 2 is even, minus 2 is also even. Agree? So, A minus B is even means minus of A minus B is even. Clearly, multiply with negative sign, I mean remove the bracket, minus A, minus of minus plus B. That means modulus of B minus A is even. Modulus of B minus A even means B comma A belongs to the R. That means if A comma B belongs to R implies B comma A belongs to R. As per the definition, R is a symmetric relation. Next, check the transitivity. Let us check the transitive relation. If A comma B belongs to the relation and B comma C belongs to the relation, this means modulus of A minus B is even and modulus of B minus C is also even. Let us take 2 is even, 4 is even. 2 plus 4, which is 6, is also even. So, modulus of A minus B plus B minus C. Here, minus B plus C. We are left with modulus of A minus B is even. Therefore, R is a transitive relation. Since it is reflexive, symmetric and transitive, it forms an equivalence relation. Also, the given set is 1, 3, 5. A minus B means 1 minus 3, minus 2, which is even number, 1 minus 5, minus 4, which is an even number. Then 3 minus 5 minus 2 is again even number. Therefore, all the elements of the set 1, 3, 5 are related to each other. Again, in the set 2, 4, 2 minus 4, or else you can take 4 minus 2, both are one and the same, which is equal to 2, is an even number. This means all the elements of the set 2, 4 are related to each other. But, see this, 1 minus 2, 1 minus 4. 1 minus 2 is minus 1, is not an even number. 1 minus 4 means minus 3 is not an even number. Again, 3 minus 2, 3 minus 4, which is 1, not even number. Minus 1 means modulus of minus 1 and 1 antane aitu. So that means not an even number again. 5 minus 2, 5 minus 4. So these are all not even. That means no element of the set 1, 3, 5 related to any of the elements of the set 2, 4. Next, 10th one, an exercise problem again. Show that the relation R in the set A is equal to the set of elements X belongs to Z, such that X greater or equal to 0 and X less or equal to 12 is given by the relation R is equal to the set of order pair A comma B, such that modulus of A minus B is a multiple of 4. So only the first part is appeared in the year 2016, annual 2016 in 3 mark section. And the second part, the relation R is equal to set of order pair A comma B, such that A is equal to B is an equivalence relation. We are supposed to prove this as an equivalence relation. To prove equivalence relation, we need to check reflexive, symmetric and transitive relation. Also, find the set of elements related to 1 in each case. Of course, this is in AIC BSc also 2010. Let me work out the first case. Okay, this is left has a practice problem. Given A is equal to set of integers such that X greater or equal to 0, less or equal to 12. That means including 0, including 12. That means the set A becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. That is the given set, right? The given relation R equals set of order pair A comma B such that modulus of A minus B is a multiple of 4. Let us verify reflexive property. For all A belongs to the set A minus A, modulus of A minus A means 0. 0 is divisible by 4 of course. So this implies A comma A belongs to the relation. Therefore, R is a reflexive relation. Let us verify symmetric relation. If A comma B belongs to relation implies modulus of A minus B is divisible by 4. If 2 divides 4 means 2 divides minus 4 also. So, modulus of minus of A minus B is divisible by 4. 4 divides A minus B means 4 divides minus of A minus B also. Remove the bracket, I mean multiply with negative sign. Minus of minus plus B minus A. Modulus of B minus A is divisible by 4. That means if A comma B belongs to the relation implies B comma A belongs to the relation. Therefore, R is symmetric relation. Let us verify transitive relation. If A comma B belongs to R and B comma C belongs to R, this means A minus B is modulus of A minus B is divisible by 4 and modulus of B minus C is divisible by 4. Therefore, A minus B and B minus C is divisible by 4. For example, 2 divides 4 and 2 divides 8. Because 2 divides 4 and 2 divides 8 means 2 divides 4 plus 8, that is nothing but 2 divides 12 also. So that modulus of a minus b plus b minus c is also divisible by 4. This means that here plus b minus b gets cancelled, a minus c is divisible by 4. A minus b is divisible by 4. That means if a comma b belongs to R and b comma c belongs to R, implies a comma c belongs to R. Therefore, R is a transitive relation. Since it satisfies reflexive, symmetric and transitive, it becomes an equivalence relation. Also, the set of elements related to 1 is equal to the set of elements belongs to A such that modulus of a minus 1 is multiple of 4. So, suppose if I take a as 1, 1 minus 1 is 0, 0 is multiple of 4, divisible by 4. If I take 5, 5 minus 1 is 4, 4 is also multiple of 4. If I select 9, 9 minus 1 is 8, 8 is a multiple of 4, right? 1 minus 1, 0 is a multiple of 4, 5 minus 1, 4, multiple of 4 again, 9 minus 1 is 8, is again a multiple of 4. The next 11th one, an exercise problem. Give an example of a relation which is, there are 5 cases. A, symmetric but neither reflexive nor transitive. The second one, transitive but neither reflexive nor symmetric. The third case, reflexive and symmetric but not a transitive relation. D, reflexive and transitive but not symmetric. E, symmetric and transitive but not reflexive. Please listen, if it is to be reflexive, for all the elements of the set A comma A belongs to the relation. If it is to be symmetric, if A comma B belongs to R, then B comma A belongs to R, symmetric. Transitive means if A comma B belongs to R and B comma C belongs to R, then A comma C belongs to R. This is the definition we know. Let us take a set as, instead of 1, 2, 3, let me take 5, 6, 7. I want a symmetric but not reflexive and transitive. Let us select the relation R1. If it is to be symmetric, 6 comma 7 means 7 comma 6 must be there. So that means I just include 6 comma 7 and 7 comma 6 is only symmetric, It is not reflexive since 5, 5, 6, 6, 7, 7 must be there if it is to be reflexive. So 5 belongs to the set A, but 5 comma 5 does not belongs to the relation R1. That means it is not reflexive, So to check a transitive relation, 5 comma 7 belongs to relation, 7 comma 6 belongs to relation, A comma B and B comma C belongs to relation means 6 comma 6 should be there in the set, but 6 comma 6 does not belongs to the relation R1. That means it is not a transitive relation, So similarly, you can give one more example. R2 is equal to 5 comma 6. 5 comma 6 means 6 comma 5 must be there if it is to be symmetric. I don't want reflexive. 5, 5, 6, 6, 7, 7, it is not there in the set. 5 comma 5 also not belongs to set. That means it is not transitive also. I have given the explanation to you. Second one, we want only transitive but not reflexive, not symmetric. Let us select the relation R1, 5 comma 6, 6 comma 7, and 5 comma 7 should be there if it is to be transitive. You check any order pair along with 5 comma 6, 6 comma 7 means 5 comma 7 should be there in the relation. Then 6 comma 7 along with 6 comma 7 you can't take this, you can't take this. That means the second order pair itself is not there in the relation. So you can say it is transitive. Come to this one, 5 comma 7 along with 5 comma 7 you can't take 5 comma 6, you can't take 6 comma 7. That means it is transitive for all the order pairs. But 5 belongs to the element, 5 belongs to 5, the element 5 belongs to the set A. This implies 5 comma 5 does not belong to the relation. Even 6 6 does not belong to relation, 7 7 you can write. That means R1 is not reflexive relation. Then 5 comma 6 belongs to relation, but 6 comma 5 does not belong to relation R1. That means R1 is not a symmetric relation. So therefore R1 is only transitive but neither reflexive nor symmetric. Another similar example, R2 is equal to 5 comma 7 and 7 comma 6. 5 comma 6 must be there. So then only it is transitive. You can verify for the other elements also. So 5 5 does not belong to the relation R2. It is not reflexive. 5 comma 7 belongs to R2 but 7 comma 5 does not belongs to R2. That means it is not symmetric. Let us take the third case. It is reflexive and symmetric but not transitive we are supposed to say. So since the set A is 5 6 7, if it is to be reflexive, 5 5 6 6 7 7 must be there for every element of the set. A comma A belongs to the relation, if it is to be reflexive. So 5 5 6 6 7 7. I want symmetric also. Let us take 5 comma 6. 5 comma 6 means 6 comma 5 must be there. If I select 6 comma 7, 7 comma 6 must be there if it is to be symmetric. So these relation R1 is reflexive and symmetric. But observe here, 7 comma 6 belongs to relation. 7 comma 6 belongs to relation R1. 6 comma 7 belongs to relation. But 7 comma 5 does not belong to relation. That's why it is not a transitive relation, not a transitive relation. And another relation R2, similar one. So if it is to be reflexive, 5 5 6 6 7 7 should be there. And if it is to be symmetric, if I select 5 comma 6, 6 comma 5 must be there. 7 comma 5, if I select 5 comma 7 must be there. So it is reflexive and symmetric but not transitive. Why? Because 6 comma 5 I will select 6 comma 5 and 5 comma 7. 6 comma 5 and 5 comma 7 belongs to R2 but 6 comma 7 does not belong to relation R2. That's why it is not transitive. Let us take D. Let R1 is equal to 5 5 6 6 7 7 if it is to be reflexive and even transitive, but we don't want a symmetric. So I just select 5 comma 6. So now 5 comma 6 belongs to the relation R1 but 6 comma 5 does not belong to relation R1. That means R1 is not a symmetric relation, not symmetric relation. Okay, so it is reflexive and transitive also. Reflexive means 5 5 6 6 7 7 all the elements are there. Along with the 5 comma 5 you can't take this, you can't take this. If I select 5 comma 6, so 5 comma 6 is there. Okay, then this is got over. Along with the 6 6 you can't take this, you can't take this, even you can't take this. So second order pair itself does not exist means it is reflexive. Along with the 7 7 you can't take any of the order pair. Along with the 5 comma 6 you can't take this, you can take 6 comma 6. 5 comma 6 and 6 comma 6 means 5 comma 6 it is there. You can't take this also. So therefore, for all the elements it is transitive. Next. Similarly, R2 5 5 6 6 7 7 6 7 I have chosen. So 7 comma 6 does not belongs to R. It is not transitive, whereas it is reflexive and transitive, not symmetric I mean. Next, I want only symmetric and transitive but not reflexive. Not reflexive means 5 5 6 6 7 7. Any of the order pair is removed from the relation, it becomes not reflexive. So let us take R1 is equal to 5 6. 5 6 means 6 comma 5 must be there if it is to be symmetric. 5 5 the order pair, revert it, 6 6 it is there. So it is symmetric. Transitive means along with 5 comma 6 you can take 6 comma 5. So we are left with 5 5, it is there. Along with 5 6 you can't take this one. So you can take 6 comma 6. 5 comma 6, 6 comma 6 means 5 comma 6. So this is transitive. Along with the 6 comma 5 you can take 5 comma 6. We are left with the 6 6. It is there in the relation. With the 6 comma 5, 5 5 we can take. Again we are left with the 6 comma 5. It is reflexive, I mean transitive. With the 6 comma 5 you can't take 6 6. So 6 comma 5 got over. Along with the 5 5 we can take 5 comma 6. We are left with 5 comma 6, it is there. Along with the 5 5, 6 5 we can't take, 6 6 we can't take. So only 5 5 is transitive. Then along with the 6 6 you can't take this, we can take this means 6 comma 5. We are left with the 6 comma 5, it is there in the relation, you can't take this. So for this also it is transitive. But 5 5 6 6 is there, but 7 comma 7 does not belongs to relation. That means it is not reflexive. Similarly, another example, R2 equals 6 comma 7, 7 comma 6, 6 6, 7 7. 12th question, an exercise question. Show that the relation R in the set A of all points in a plane given by R is equal to the set of order P comma Q such that the distance of the point P from the origin is same as the distance of the point Q from the origin. This is how the relation is defined. Is an equivalence relation. Further show that the set of all points related to a point other than origin, not origin, is the circle passing through the point P with origin as the center. Solution. Given R is equal to the set of order pair P comma Q such that the distance of the point P from the origin OP is same as the distance of the point Q from the origin. That is what they have given. Distance of the point P from origin is same as the distance of the point Q from the origin. Instead of writing the verbal form, I have written the mathematical expression OP is equal to OQ. Is a relation on the set A of all points in a plane. Let us check reflexive relation. As modulus of OP, length of OP is, that is the distance of the point P from the origin, is equal to the distance of the point P from the origin. As these two are equal, P comma P belongs to relation. For every P belongs to the set A. Therefore, R is a reflexive relation. Symmetric relation. If P comma Q belongs to relation, means the distance of P from origin OP is equal to the distance of the point Q from the origin OQ. OP equals OQ is same as OQ is equal to OP. That means the order pair Q comma P belongs to R if P comma Q belongs to R. Therefore, R is a symmetric relation. Let us verify transitive relation. if P comma Q belongs to relation and Q comma T is another point belongs to relation. This means the distance of the point P from origin OP is equal to the distance of the point Q from origin OQ, and OQ is equal to OT. So this and this holds means OQ, OP is equal to OT. The distance of the point P from origin is same as the distance of the point T from the origin. So that means P comma T belongs to R provided P comma Q belongs to R and Q comma T belongs to R. Therefore, R is transitive relation. R is a transitive relation. Since it satisfies reflexive, symmetric and transitive, it forms an equivalence relation. It forms an equivalence relation. Also, say this. This is the fixed point. Here is the point P. See, this is how it moves. See, the distance of the point P from the origin. If point P moves somewhere here, then this distance is also same. This distance is also same. So that means set of all points. These are the set of all points related to P other than origin will be those points from the origin. This is the distance from origin. This is the distance from origin. Those points from the origin is same as the distance of the point P from the origin. So these set of points forms forms a circle with the center at origin and the circle passing through the point P.